This meeting is being recorded.
Okay, welcome everyone to this week's OMR Architecture Meeting. This week we have one topic. Mark Studley will be talking about JitBuilder 2.0, so sort of the evolution of JitBuilder. So I'll turn it over to him to take it away.
Thanks, Daryl. So this is a very hastily prepared presentation. In fact, I just finished putting my name on the first slide just before we started here. So it's going to be a little bit rough, but the point of me coming to the meeting now to talk about this is because I think I have enough to really talk about, and I have a bunch of ideas and a bunch of, I built a bit of a prototype for myself over the Christmas holidays, which is now more than 2 months ago. And so I wanted to start talking about this with the broader group and see what people's thoughts were, see if the things that I did in the prototype sound attractive, and if people have thoughts on where we should go further with this. So I wanted to start just by what got me going down this path was sort of sitting back and thinking a little bit about a lot of the feedback and points that people had made over the last couple of years that JitBuilder has been around, and trying to address some of the user scenarios that JitBuilder wasn't really originally designed to fit. Maybe I should take a step back and talk about why JitBuilder is what it is today. So the origins of JitBuilder actually predate our going open source, and in fact, it was a hedge against our ability to open source the compiler technology as early as we did. I was trying to create an API to the OMR compiler that we could open source independently of the compiler itself. And as part of that exercise, I was also trying to sort of drastically simplify what it was you had to do in order to write a compiler. Since as part of that effort, I'd kind of gone through the process a few times, and it was reasonably painful, the number of things you had to hook up and configure and get going before you could even sort of start really writing a JIT compiler for a language, which is kind of what you usually set out to do from the get-go. So I was trying to simplify that process. And so what I ended up creating was really an API that just kind of sat on top of the OMR compiler and passed through the things that you were asking it to do down to the OMR compiler, which meant that people using JitBuilder had a set of concepts that they were working with, which were defined by the JitBuilder API. But then all the actual work was being done by the OMR compiler, which is a completely different thing with different concepts, different organizations. And that, the sort of bimodal or the two aspects are confusing for some people, especially if you really want to see what you're doing with JitBuilder. And so that was one of the main goals. I wanted to try and bridge this dual mental model that you have if you really start looking deeply into what JitBuilder is doing. And some people had expressed some difficulty in kind of managing that duality. And where it kind of surfaces a lot is when you're trying to do logging, debugging, analysis. So when you're trying to, it's all well and good if you know exactly what you're trying to do and you write exactly the correct JitBuilder code right from the start. But if you happen to make a mistake, figuring out that you've made a mistake wasn't always a straightforward process, and it was hard to do that if JitBuilder was your mental model of the world. So I wanted to fix some of that. In addition, I was hoping to improve on some of the extensibility of JitBuilder. We took some steps in this direction with the API, but it was never really an easy thing to add new types or new operations without going all the way down into the OMR compiler and providing lots of, sort of lower level support for doing it. And as sort of part of this extensibility aspect, it struck me that it would be very useful to be able to operate on the JitBuilder representation itself. So if you think of the calls that you make to JitBuilder as building a data structure as opposed to being a pass-through API into some other thing, the OMR compiler, that started to feel to me like a more usable mechanism. I was hoping to provide an easier experimentation path for new compiler concepts, so not forcing everybody to go all the way down to the OMR compiler, the way that the OMR compiler frames things in order to try out new stuff. A wild and crazy idea I had was that maybe this new thing could provide an evolutionary path from the OMR compiler, the current OMR compiler's IL to something else. So if it could actually extend, if you could extend it down so that it actually could encompass what the OMR compiler IL currently looks like, you could use it as a path to evolve the IL in a different direction without necessarily losing backwards compatibility with all the existing things that depend on the compiler IL, which is really kind of a decoupling story. So this isn't to say necessarily that I want to decouple JitBuilder from the OMR compiler, but I was hoping to get the sort of freedom to play without pulling in all of the OMR compiler, easier ability to have kind of client and compiler, client versus server kind of scenarios. Maybe make it easier to bring it to other languages, and one that kind of pops up from now and again, you make it a little bit more distinct from OpenJ9 so that maybe there are fewer constraints on how it evolves going forward. It's still, it's kind of a fact of nature that OMR and OpenJ9 are fairly linked in a lot of ways, and so it's hard to change some things without making changes in both projects. I was hoping to provide a place where we could do, things that you could just do it in JitBuilder and not have to worry about what you would do to OpenJ9, because you wouldn't be affecting OpenJ9 at all, which has pluses and minuses, of course. Anyway, so that's, kind of a grab bag of interesting things that I was hoping to accomplish with JitBuilder 2.0. Where I am right now is nowhere near to accomplishing almost any of these. But it did provide sort of a way to start, and I wanted to mention these just because they are things that I guess I've collected over the years as sort of issues with the OMR compiler and with JitBuilder 1.0. Not that we ever used that naming, the current JitBuilder API. All right. So as I mentioned, over the last Christmas holidays, I used some of my time to basically start prototyping and creating a relatively independent implementation of a new kind of JitBuilder, which is largely incomplete, but it was complete enough to run a matrix multiply example that I've been working with, just because it doesn't have too many operations in it and doesn't do anything too wickedly complicated, but it does do control flow and it does operate on values. Right now, the prototype is completely independent of OMR, but that's mainly because I just haven't written the code generator to generate code down into the OMR compiler. That's not to say that I don't think that's something I should do. In fact, I had hoped to do that before I came to talk to this group about it, but in the interests of moving forward, and given I haven't had enough time to do it, that's kind of where we are. It does include some interesting rudimentary logging and allows you to pretty print JitBuilder IL. So as I mentioned before, I wanted it to be a representation that stands on its own. So there is now a JitBuilder IL data structure that you build when you're calling JitBuilder API functions. And then I also did some interesting sort of prototype experiments. I'll talk a little bit more later on about it rather than worry about it here. So there's a lot of JitBuilder 2.0 things that look very similar to the existing JitBuilder things, although there are some twists. I did simplify some of the names. Some of the familiar concepts are there's still a thing called a builder, which used to be called IL builder. I just decided to take the IL out. It has a subclass called FunctionBuilder, which used to be called method builder. I'm not quite sure. I never really liked the method builder name. It felt like it was just carrying stuff from Java that wasn't really appropriate. I felt weird talking about a native C-like function that was called a method. So I changed that to FunctionBuilder. The other builder types would come along with this, but I haven't implemented them yet. Type is, I did the same thing with type as with builder. I just took off the IL. There's still a type dictionary, and there's a thing called value. All of these things are in the OMR JitBuilder namespace, so they don't pollute anybody else's life. And then there are a few different new things that I brought in here. So I created a thing that's very simple right now called config that just allows you to specify some configuration for things like do you want to do logging or not? Do you want to, are you trying to debug the transformations that are being done by a transformation operation, that sort of thing. I stole the concept of dialect from MLIR, I guess. Stole is a bit strong. It's really just a concept. It's the idea that you could layer, you'd have different layers of operations that you could use, and in a particular dialect, you'd be restricted to using a certain subset of the operations. And if you had, I guess the goal there was if you had a transformation that was written for a particular, that knew about a particular set of operations that were part of a dialect, you wouldn't be able to necessarily apply that to another. If somebody added new operations and defined a new dialect, the transformation might not directly apply to that, but you might automatically be able to reduce it to the dialect that the transformation was written for. Operation is another key thing that doesn't exist in the current JitBuilder API, because you can't talk about operations independently of just calling them. So in JitBuilder, you call things like add, sub, load, for loop, up. I now call those things operations, and they actually are a data structure that represent the actual action that's being performed. There's an enum that lists what the operations can be, and they're also subclassed. I introduced a concept of symbol for local symbols, parameter symbols. Obviously, there's a whole hierarchy of symbol types that could be introduced here, but I've only done those two for now. One neat thing is a type graph, which is essentially stores the valid kinds of types for values that you can pass into an operation, so that you can validate the calls that you're making on the fly. Basically, as soon as you make a call to create an operation, it will validate that it's a proper kind of operation, and it can give you a meaningful error message if you don't do it properly, if you try to mix and match types that don't actually fit together. And then I defined some very, very simple traversal types, a thing called visitor, which probably you can guess what it's like, and transformer, which is just like a visitor that allows you to rewrite an operation with an arbitrary bit of code. And I'll talk about some of the examples of things that I wrote using this framework. In red are the things that I'll talk a little bit. Actually, type should be in red because I think it appears here too, but I won't focus on everything in this talk. All right, but before I get to that, I'll talk a little bit about some general improvements and things. So everything that I just talked about is a data structure, so it becomes part of the data structure that you build when you're using JitBuilder. So values, types, symbols, operations, builders, etc. They all create data structures. Each one has an ID, and potentially you can even give it a name. So for instance, a builder object, you could give it a name if it corresponds to it, if that's a meaningful thing for you to give it a name. Everything can be queried and traversed. This slide's already out of date because I changed the names of the queries already since I wrote this slide. But basically, you can ask an operation, what are its operands, what values does it operate on, what are the results that it produces, what are the types that it works on, etc. It's aimed for backwards compatibility. I put it in quotes because it's not really backwards compatible, but I'm hoping that most of the changes that one would need to make in an existing use of the JitBuilder API would be fairly straightforward and mechanical to change into the new model. Although there are some things that that are a little bit more painful than others. For example, in the JitBuilder API now, it uses pointers to things a lot, like a pointer to a value, a pointer to a type, a pointer to a builder object. And in a lot of cases, I've changed that to references just as an experiment to see what it looks like. that may change in future. I've also removed some of the double pointer arguments right now. So, for example, if you were to call if then else and pass it the address of the then builder variable and the address of the else builder variable, if those two variables were set to null, it would automatically allocate you a builder object and store it there. I've changed that so that you now have to call AppendBuilder to create a builder and pass it in, just to simplify the API a little bit. It cleans things up a bit too. I think that's as much as I'll stay there. I'll say there. All right. So I'm going to go through a bunch of the facilities now, I guess. I don't know, classes. Need a better word for this. And just kind of talk a little bit about what they look like, what kind of API they expose to the world. And again, I want to emphasize this is a prototype that I wrote. It's not something that's cast in stone or that it has to work this way. I'm describing a thing that I came up with to see what people think of it and as a mechanism to get concrete feedback. But I'm by no means attached necessarily to how these things are all there as I describe them here. All right, so the I guess lowest level fundamental piece here is a value, right? So a value is just some type of data that you operate on. And because I wanted the API or the representation to be extendable and for people to be able to add their own types and to add their own operations in here, it really is some kind of data, right? It's not it's not necessarily a primitive kind of data. It could be a record, it could be an array, it could be all kinds of different things. It could be a tensor, whatever. And so right now, at this exact moment, the public API of value is right there. And the third one is probably not something that really needs to be there. It's just, you can ask for its ID and you can ask for its type. And this used beyond parent thing is just an interesting little toy thing I put in there to identify if a value is used outside of the builder in which it was created, i.e. is it used further away than just a very local context. You are not allowed to create a value directly yourself. You have to call an operation on a builder object in order to create a value. And only builder really gets this privilege right now. The main reason for this was to just maintain a control point on how values get introduced into the system. And so that it's harder to get it wrong because the user doesn't have any control over it. So the type of a value obviously kind of categorizes what the legal data is that value can have. And sort of new in this prototype, you can ask the value for its type. And that type is a real type. Like, it's not just the primitive type like it used to be. You used to be able to ask a value what its primitive type was, which actually corresponded to the OMR compiler's TR data type. But if you were talking about a value that was looking at a struct, you would actually get back a pointer type because it's what you're really talking about is an address to something. In the new scheme, if you're a better example would be if you had a pointer type, you could be pointer to pointer to pointer to int64. The type that it would tell you is address because that's a pointer type. It doesn't tell you the details about what it is. But now you can ask for the JitBuilder type of something. And so if you are actually working with a pointer to pointer to pointer to int64, the type of a value of that will be pointer to pointer to pointer to int64, and you can actually manipulate that type and look at it. And then if you perform operations, like if you dereference that value, it will strip off one of the pointer twos in the type of the value that it returns. So you can actually query the real value of something now. An open question here is whether or not value will become an immutable thing. It's sort of an immutable thing in the current JitBuilder API, and it sort of isn't. There are facilities like the virtual machine operand stack, for example, that will overwrite what a value is if it learns of a new control path that it needs to add things into. I would like to move this to an immutability rule about values that you cannot overwrite them, but I haven't thought about it very carefully in the context of how virtual machine operand stack would be implemented in this. I think we get a lot of value here in being able to walk and traverse the existing data structure that's being, like IL that's being created from a JitBuilder call, so that I think virtual machine operand stack will be able to do what it does today without needing to introduce mutability of values, but I have to think about that a little bit harder. But that's a direction I'd like to go in, is to make value immutable. And I think that's all I was going to say about values. I should probably pause here because otherwise I'm just going to keep talking for another half hour on different things and I'll miss questions. So does anyone want to inject a question at this point? Everyone's giving me WTF looks in the room. Okay. Did I not do a good job of motivating what it is that I'm trying to do? Again. Okay. Okay. All right. Any questions on the phone before I continue along? I'll take that as a no. All right. Okay. So stepping up from value, probably should have talked about type as well. Maybe I have type here somewhere. Anyway, I just put these slides together. I'm sorry, I'm not fully remembering everything I have in here. Operation is the next sort of level up. So an operation is something that does something, right? Again, because I want it to be extensible and for people to be able to define their own things, it's hard to lay down a more specific definition than it's a thing that does something. So OMR JitBuilder operation is an abstract base class for operations, which identifies what the actual action is using an enum. So I gave an example of some of the things that are in the enum right now. Add, sub, load, store at. These will be familiar to people who've used JitBuilder before. And you can ask an operation what its action is by asking for action. Every operation has a parent builder, which is where this operation resides. So operations aren't allowed to float around. They have a place where they are in the universe, and that parent builder is the one that's, I'll talk about builder in a sec, so don't get held up on what a builder is yet. And basically there's a public API for querying what things are there in an operation. So operation itself defines some generic things, and the reason why you want to have generic things is so that you can write optimizations that don't necessarily have to know if it's an add or a load or an if and else to query what operands it works with or what results it produces or what types it's going to operate on, or whether or not it's got literal values and so on. And there are also iterators, which are sort of based around the same type of iterator API that STL offers. So you get a begin iterator, you iterate until it's the end iterator, and you can dereference it to get the value that's at each operation. So you can ask for operands begin, you can plus that as long as it's not equal to operands end, and you can dereference the iterator, and you'll get that value in the iteration. Similarly for results and for types and for any builders that are referenced in the operation. There are also concrete subclasses for each of the kinds of the actions. So there's an add class, there's a subclass, there's a load class, store at, if then else, for loop up, etc. So if you want to define a new operation of your own making, you have to create one of these subclasses. You have to add it to the an action to the enum to correspond to it, and then you'll have to implement some of these public interfaces to be able to say, how many operands it's got, how many results it's got, what types it operates on, if it has any builder objects, etc. And you can obviously add special API that's specific to your new operation if you want to at that point. Okay.
May
so
I have
building
a question?
up from. Sorry, go ahead.
I just wanted to ask: is operation a value?
An operation is not a value.
Okay.
In the prototype, anyway.
Okay. Thank you.
Okay. So builder is a sequence of operations. So This isn't any different from the current JitBuilder API. I was just trying to come up with some sort of simple explanations for what these things really are. So a builder, let's say it's basically a control flow. You can think of it like a control flow label, so things can jump to it, direct control to execute what's in that builder, and then it will perform a sequence of operations. And those operations may themselves introduce additional control flow internal to themselves. But basically, if you start executing a builder, unless you leave the builder, you will continue just executing the sequence of operations one by one. It's not a basic block. It's more complicated than a basic block. And again, that boils down to why the operations can be more complicated and higher level than the operations that we typically see in a compiler. Right, we have in JitBuilder, we have operations like for loop, which are more complicated than just an add or a sub, right? They have internal control flow. So anyway, every builder is contained within a function builder. It has a parent function builder. I'll talk about function builder in a sec, just to clarify what that is. And then I introduced something of a, this was a bit of a murky area in the original, or the current, I guess, JitBuilder API, is that some operations that you call, like I gave the example, if compare greater than, are basically just a branch to another builder, and there's no promise that it's going to come back or not. And if you want it to come back, you have to explicitly do something to make that other builder come back to, like, to merge back. There's no implicit merge back. And I decided to call that an unbound builder. So it's unbound to the operation that directed you there, right? So, so if compare greater than branches to a builder that's not bound to the if compare greater than operation. In contrast, if then else is going to use two bound builders, because if then else is really creating a control flow structure that includes the merging of those two control flow paths. And so if you, in the current API, you can actually put a branch at the end, like a go-to at the end of one of those builders, and it will go away. But I'm changing that model here in that if you want to do that, I'm going to direct people to use the if compare greater than, because it doesn't have any restriction on the flow back from the builder that you're branching to, whereas an if then else, because it's creating that diamond data structure, the flows are already determined. So, and the reason why you need to do this, or the reason why I went down this path, is to motivate things like data flow analysis, where you have to know how to flow values around through operations. And so the notion of a builder being bound or not helps you figure out how values flow through these operations to the builders that they refer to.
Okay, sorry, just make sure I understood correctly. So an unbound builder is basically like kind of like doing a go-to to a builder.
Yeah.
A bound builder, well, it may be conditional,
yep.
A jump.
Yes.
A bound builder is more like a call, and that there's an expectation you're going to go somewhere else, do stuff,
and come back,
and then come back and.
Yes. So yes and no. So yes, because yes, because it kind of is the case that the builder is it. If you look at the builder in isolation, you somehow get there. It gets called by something else, and then it goes back to wherever it got called from. I want to say no, even though it probably is more accurate than I'm giving it credit for. The way that the outer service lays it down. I guess I was more trying to say that it's the operation that directs control to the builder that determines what happens after the builder completes. So I didn't want to necessarily restrict that to a call return type flow. Like it could be controlled to go somewhere else. It wouldn't necessarily be, absolutely a call return type.
Fully
flow.
encapsulated kind of
Yes.
the control flow of the thing that you're putting down here.
Right.
And then what comes after it is therefore in the hands of the caller.
Right. And so what that means is that if you have a bound builder, you're not really allowed to have it unconditionally branched somewhere. So you can't put a go-to at the end of a bound builder, for example. Even though in principle you probably could, but it seems like a useful rule for trying to validate when you're putting proper control flow together. Right, okay. Operations are validated as they're created. So as you're calling each operation, it's going to validate using a thing called the TypeGraph, which I'll talk about in a second. And it basically maps the operands that you pass to the operand to the operands that you pass to this operation. It validates that that combination of types for this operation can produce a valid value, assuming that it's a thing that produces value. And if there is no such production, then it will assert at that point and give you a indicative error message. Each of the operation classes registers the valid combinations themselves, right? So again, if you want to be able to extend it, you want to be able to add your own operations. So like nothing else knows what the correct combinations are in the thing that you're adding. So you put the responsibility there. And then things like using pointer to with TypeDictionary, I'll actually show this a little bit lower, registers a valid addressing for that type to say I can only dereference a pointer to int64 and get an int64. I can't expect to do anything. Or when I do that, I get an int64. So that's partially how it gets the proper types for the values that you're working with. FunctionBuilder is really no different than the current JitBuilder API, other than the fact that it's called FunctionBuilder rather than Method Builder. It has a name, it has parameters, so that it's basically a callable builder. It's a builder that you expect to be called and passed off operands or arguments via parameters. But other than that, it's just a sequence of things that execute. And then if you want to make more complicated things, you just add more complicated operations as part of that list, which is no different than the current API.
Is a builder analogous to a basic block, or
It's more complicated than a basic block.
Okay.
Because there can be internal control flow, right? A basic block. Okay. A basic block, if you execute the first instruction in a basic block, you'll execute everything in the basic block. That's not necessarily guaranteed in a builder object. It would be hard to guarantee that, I think. So it's a little bit more generic. However, I didn't talk about it very much in here, but maybe given that you asked that question, it might be the right time to mention it. So I had on my whiteboard at one point a description of, I had a notion of defining a special kind of builder called a block builder, which would actually be a basic block, and it would have that restriction that you can't go anywhere else, and it would probably work with very low-level operations at that point. So you wouldn't be able to put, say, a for loop into a block builder. You'd only be able to put an if CMP, and if you put an if CMP into a block builder, that would kind of close off the block builder at that point, right? So it would be a more traditional notion of a basic block from a compiler's perspective. You could also imagine an extended block builder, which would model what our extended basic blocks look like in the OMR compiler. And that's sort of how I started down the path of maybe this could actually be a different way to represent our existing IL, and so provide a way to do sort of higher level optimization stuff first, but eventually be able to lower it down into a model that looks very much like what the OMR compiler's IL looks like, and then just becomes a straightforward translation into it.
So at what point would you have different builder objects? Because if the builder object is a sequence of operations, then you can have internal control flow.
Yep.
Couldn't the whole program just be one big builder? Like, when would we have different builders?
You need different builders to be able to represent different entry points, right? So if you're doing an if then else, that's one operation, but it has two builder objects associated with to correspond to the then path and the else path, right? A for loop has a loop body builder that's where you put the operations that you want to be iterated on by the for loop operation. Okay. And you can also tell it that it can also give you a break builder. So if you need to jump to a break, if you want to do a break inside the loop, you just jump to the break builder. If you want to do a continue, you just jump to the continue builder. And that's all set up by the for loop. So TypeGraph. So this is something that doesn't exist at all in JitBuilder right now, with the consequence that it's hard to know if you're doing valid things or not. If you do a valid thing, it works fine. If you do an invalid thing, you typically assert somewhere deep inside the OMR compiler, maybe not when you created it, but only later on when some optimization touched it, figured out that, hey, this isn't something that should really be here. And so I wanted to change that to drive the points of sort of error detection closer to the point when you're actually creating the thing that's wrong. And so, as well as having this advantage of being able to ask what the real type of a value is. And so I've showed an example here of how the add operation has a initialized type productions function here, which instance function, which just basically maps. Interesting. I guess I could have written that differently. I only did the 8.8 one in the short form, but anyway, mid modification, I caught this and put it into this presentation. So the idea here is that this register valid operation is a function that's provided by the TypeGraph, and it's basically saying that it produces an integer 8-bit integer result. If you use an add service and you pass two values that are an 8-bit integer and an 8-bit integer. And then the same thing if you pass a 16-bit and a 16-bit, you get a 16-bit integer and so on for all the sort of primitive types. And then down here, just for compatibility with the existing JitBuilder API, because pointer types and addressing was, not very rigorously handled in the original JitBuilder API, there's this rule down here that allows you to add any machine word-sized integer to an address and get another address, which is a very C-like thing to be able to do. But there are actually better productions produced for pointer types, which I think is on the next slide. Right. So TypeDictionary has a register pointer type guy, which is used by pointer2. So when you call pointer2 with a base type, it returns a type that reflects a pointer to that type of base type. So it could be pointer to int64, in which case this pointer type that's being passed in here would be pointer2 int64. So that registers the type with the graph, so it can create so it can link nodes based on that type. It asks what the base type is. In the example I just listed, that would be pointer to int64, because we're talking about the pointer type passed in is pointer to int64. So the base type would be pointer to int64, and then it registers valid operations for manipulating that pointer. So you can add an integer to that pointer type, and it will give you another pointer type of the same type. Basically, you're using add to index into off of a base pointer, and you're going to add elements of the size of base type. No, that doesn't show up here. A sub can be used to subtract two pointer types and get the size between them, the number of elements between it. You can index at pointer type for a word and get the address, is sort of the same thing as add. Synonym for add, I guess, in this case. If you do a load at for that pointer type, you'll get the base type. And if you do a store at with that pointer type and that base type, it doesn't return anything. So it says that that's a valid operation combination. So and it will do that for any pointer type that gets created by the system. So as you create pointer types that you work with, it will add valid productions to the type graph to allow you to manipulate those pointers properly. I also created some extremely basic traversal support. So visitor, you can probably guess what this looks like, but basically it's a base class that allows you to override a set of protected virtual functions that are called at various points during a traversal of the graph it starts at the function builder, walks through all the operations, and as it visits an operation, if that operation has builder objects, it will visit those builder objects. So it's a very straightforward depth-first traversal of the graph. And then you can basically instrument at any point in that. You can get called when you're on the function builder itself, before you visit the operations or after you visit the operations. when you're going to visit a builder, you can get called before it walks through the operations of that builder or after. And you can also get called at every operation that it visits along that path. So that's not a fully general or even, you know, there are way more different varieties of useful visitations. This is just what I kind of started with from what I needed. The example that I created a visitor is a pretty printer type thing. I actually called it pretty printer. It's about 450 lines of code that basically creates a logging stream and outputs. It walks the TypeDictionary and then it walks the FunctionBuilder using the visitor pattern to basically print out a textual representation of the full JitBuilder IL that you've created. So I didn't show everything here, but this is from the start of the FunctionBuilder. So MB0 is basically, that's the index I mentioned. Everything has an index and a name so that you can search for it. This one has the name of the function. It has a type dictionary, which I didn't show, but it actually got printed out earlier on, which would define what these various types are that are being represented everywhere. I tried to make it easily easy to navigate around in the system to find different pieces in sort of the same way that we walk through JIT logs, right? So operations have an identifier that's consistent for that operation. So in a log, if you were doing transformations and you saw an op3, it would always be this op3, and therefore you could, you know, kind of search for op3 throughout the log and find out what was going on with that thing in previous operations or not. I elected to do kind of an LLVME way of writing the operations out. So if there's a result, it starts off first with an equal sign, then the name of the operation, and then all of its operands afterwards. So load takes a string, so you can see strings. Constant int 32 takes an integer value that it's going to create a constant for. For loop up is an interesting one because it takes the name of an iteration variable, a value for the base of the iteration, a value for the end of the iteration, and a value for the step of the iteration, and then a body builder B1, which I didn't show, but looks again like one of these guys, which has a list of operations, and in principle could have other attributes like these things. So I used square brackets just for the hell of it, just because I didn't want it to look like Lisp. but basically, things that are sort of part of a thing other than operations, I encased in brackets so that you could tell the extent of those things. I probably went a little bit overboard on some of these things, but it is what it is. So I find it to be relatively readable, but it's just one example of how to do this. The second kind of traversal support that I added was a thing called transformer, which is similar to visitor, except it's just a different set of things that allow you to do a transformation. The sort of key one here is this guy, which I just made it hard to read because I can't select it. Sorry. This guy, transform operation, is kind of the beefiest part of this transformer. The idea here is that you're passed, as it visits through the operations, it will pass you the operation object, and you can give back a builder object, and it will replace automatically for you. It will replace the existing operation with whatever sequence of operations are in that builder object. So basically the model is you look at the operation. If you want to change that operation, you create a builder object, inject the things that you want to replace the operation with, and then you return it. And it will automatically extract those operations out of the builder object and put it in place, stitch it together for you. So you don't have to manage the mechanics of doing that. You just have to worry about what you're trying to transform that operation into. Now, that's, again, only one of the kinds of things that you would want to do in a compiler, but there are some useful things that you can do with just this. So the first thing I wrote, which ended up being useless because I didn't need it anymore, was an AppendBuilderinliner. So the idea here was, if you look at, so AppendBuilder is just a way of passing a builder object and saying, insert this builder object here in this other builder object. And if you look at the JitBuilder IL for that, it's basically an operation that says append builder, and there's a builder object, and then that builder object has the actual operations, which is kind of wasteful. It's just kind of, it doesn't provide any real value to have that be in another builder object unless something needs to branch to that code sequence as well. So what this transformer does is it, in an earlier version of this JitBuilder IL, I ended up producing a whole bunch of these kind of append builder calls automatically, which they weren't really needed, but it simplified building out some of the infrastructure. So I wrote this little transformer thing that could kind of go through and just piece them back. It would take out the append builder and basically inline the operations in place. And so I added a facility to, well, okay, so what's the idea here? So this is just to initialize the object. The transform operation just looks to see, is this an append builder operation? If it is, check to see if the builder object that it refers to is target. So whenever somebody branches to a builder, I've just set a Boolean on the builder to say something jumps to here. And so if something jumps to this builder, then I can't inline it because I need stuff to be able to write it. Otherwise, and so if it is a target or it's not an append builder, then just return null. Don't change the operation at all. Otherwise, you can just return the builder object, and it will take those operations and inject them into the code directly, which was kind of neat. Not very much code to do that. I wanted to talk a little bit about debugging before I go through the next example. So as I was building out the Pretty Printer, so the Pretty Printer is basically a logging format that allows you to see what the code is like. But it's a little bit more powerful than that too, because Transformer and Visitor can also put into the log what they're doing. So you can track what operations Visitor and Transformer are doing as they're visiting through the IL. And in particular, Transformer supports perform transformation, which I always thought was a brilliant piece of diagnostic power inside the OMR compiler. But it's one of those things that if you don't build it in right from the get-go, it gets really, really painful to get in later. And so I wanted to put that in right from the start. And so FunctionBuilder basically counts transformations in conjunction with Transformer. And it also has a nice, because of the Pretty Printer functionality, you can actually print the operation before and I shouldn't say trees, the operations that you're transforming it to, it can print it out directly in the log. So for example, there's another transformer I wrote, which was, I called it a dialect reducer, but the idea was that it would reduce higher level functions, kind of like what I was talking about with Irwin before. It could take for loop up and it would break it down into more like a basic block kind of notation. And so all it does is it injects, it turns this for loop over K into store the initial value into K, load K into a value so that I can use it in this if compare greater than or equal to. If the loop should iterate, then go to the loop body, which is this B15 thing, which I haven't shown, and it's going to include B3 from the original guy. And then there's an append builder of B13. B13 is the continue builder, maybe the break builder, I think. Actually, I can't remember why B13 is there now that I think about it. Because B15 is actually because it has this label mark, it's the break builder, right? So anything inside B3, if it wants to break from the loop, it'll branch to B15. I can't actually remember where B13. Oh, B13 is, sorry, it's the loop. It is the loop continue. So I haven't shown it, but that would have the bump K by 1 and check to see if it's less than N still, and if it is, then branch back to B15, right? So this is the control structure that's needed to implement this loop, the for loop. And so like 2 is the transformation number that's appended. So you can actually say, I don't want to do transformation 2. If you run the code, you can set it in that config that I mentioned at the beginning, and it just wouldn't do this. But if you do it, then it shows the original operation, just op12, and then this is the transformed code that got generated for this operation as it translated.
I would want to read that line, so for loop up a.
So for loop loops, yeah, the iteration variable is k, so it's going to loop over k, and then it's going to loop from the value v4 to the value v3, which would be things that were computed above, right? So this is like from 0 to n minus 1 by 1 would be v5, right? And then the loop body is the builder b3.
So B3.
So B3 is the contents of the loop, which I haven't shown here because I didn't have too many space on the slide. So I know it's hard to read when you can't see it all. And that kind of got me to the end. That's as much as I had time to write for today. So there is one other sort of level of experiment that I performed on here. So I've talked about extensibility, but I also put the proof to it a little bit, although it's currently not in a state that builds. So I mentioned that the example I used was matrix multiply just because it has a relatively contained set of operations to work with. By default, JitBuilder defines a type called double, so you can do or integers, you can do matrix multiply over doubles, but it doesn't define a complex type because the OMR compiler doesn't have a complex type. And so what I did to extend that was I created a new type called complex, which is just a record that contains both a real and an imaginary part. I created a new operation called const complex. I also created conjugate and magnitude, but nothing used them, so it wasn't very useful that I created those. But const complex you need. And then I modified the original matrix multiply, which is the same code sample basically that's in the project now. And the only real changes I had to make were to change the types of the parameters to be complex instead of double, which is basically literally changing the word double to complex in a few places. And then when you're initializing the dot product inside the matrix multiply, rather than initializing the sum variable to a const double of 0, it's a const complex of 0, 0. And that was the only change I had to make to the client code in order to have it operate on a completely new type that did not exist in JitBuilder itself. And then on top of that, obviously, you can't run that code. Well, I can't run anything right now, but to convince myself that I could run that code, I wrote a complex reducer transformer, I called it, which is based again on that transformer class, which basically visits all the operations and replaces any use of complex values with two double values. It basically creates a map, and if it has a value that is identified as a double type, then it maps that value ID to two new IDs for the double values that have the real and imaginary parts. And then as it walks through the operations, if it sees anything that has a complex operand, it does the mapping to get the two double values, and then it generates two new operations which do the individual parts of the double operations and potentially generate new double results, which corresponds to the original complex, any original complex result, and so on. And so it manages to go walking through this whole thing and basically reduce a matrix multiply to a complex matrix multiply, sorry, reduce a complex matrix multiply into a matrix multiply that operates on two doubles at each element of the incoming arrays and generates two doubles in the outgoing array. And it does that all with about, I don't remember the exact number, it's about 400 or 500 lines of code, something like that. If I can get, oh, yeah, okay, what next? I have a web browser tab that's open with a new issue, but it hasn't been filled in with very much yet. I didn't get time to do that before the meeting, I'm sorry. And I have not yet pushed my current code, which I don't know, it's about 5-ish thousand lines of code to do what I've got. I don't think all of it's necessary. Some of it's kind of older versions of it, so I need to do some cleanup before I really push it. Yeah, I guess next step is to try and get some feedback. The whole point of this coming out was to talk to more people about what it is that I've done so far what I feel like I've accomplished so far, and to see what people think, and then I guess to just iterate, keep going. If you want, I can show a more complete example of what the log format looks like if that's of interest. But otherwise, we can stop there and chat.
Thanks, Mark. Questions, thoughts, ideas?
One quick question, mostly out of curiosity.
Mm-hmm.
You have an action enum.
Yep.
What is that used for?
It was it's so I didn't have to implement a virtual function in every subclass just to return a thing that says what you are. So it's
Okay.
Yeah, that's basically all it is.
All right.
It's use one data element to rather than a whole bunch of code elements.
Okay. Okay.
As simple as it is.
Yeah, just because it seemed, from what you showed, it seemed a little redundant. You have both the enum and all the subclasses, but
Yeah.
fair enough, I guess.
I get it. Yeah. In principle, I mean, I guess it's possible that you could go whole hog on the subclass approach, and then you wouldn't even really need anything in the base class. But I felt like it was useful to have at least some common API defined there, and I don't know, it felt silly to have everybody returning a constant. You could just store a constant
Yeah.
in the thing. And plus, I think it makes it easier for diagnostic, like when you're looking at the thing in memory, it's easier to see what you've got if you don't have symbols. You can actually look at that value rather than having to decode what class this object is to figure out what its BFT would return. Or anyway, that's I know. I've been doing this a long time, I guess, to be using that as a justification. Yeah. I was more convinced with the first answer, so I should have stopped there.
Okay, so I have few questions.
Sure. Go ahead.
The first question, I'm not sure whether I got it correctly, but you said that one of the ideas behind is to make a JitBuilder essentially a builder for a data structure. And the complete data structure is independent from OMR compiler. So in theory, you can build a data structure using a JitBuilder and then feed the data structure to another sort of compiler that can actually then generate the actual machine code. Yeah. Is that right?
Yeah, it's essentially very similar to how LLVM allows you to generate LLVM IR without necessarily generating code from it, right? You can call a bunch of functions. It will generate LLVM IR, which you can store to a file or you can print out or whatever. And then or store in memory. And then at some later time, you can say, just compile this IR that I already generated for you now, or you can write analysis passes that do analysis on the IR itself without necessarily generating code, etc. So just kind of the same basic model for JitBuilder.
Okay, that's nice. Then another question about the extensibility. Mm-hmm. Now imagine, and this is pretty wild idea, but that's something that was in my head for quite some time. Imagine you want to use that from some other language, not necessarily C++. So yep. You might have let's say a Java bindings. And now the question is how to deal with do you think it will be possible to write the code or to design the JitBuilder in a way that you can actually extend it from Java? I mean, writing a Java code. somehow.
That isn't such a wild and crazy. That's something that I've wanted to be able to do. Yes, and one of the reasons why I went down this path. I mean, I started with C++. I have done a Java client API before for, again, matrix multiply, showing that you could write Java code that leveraged the JitBuilder API. I am hopeful that it would be possible to write a language extension that could be extended in the language itself. Now, I'm sure that would come with some restrictions. Like, I don't think everything would naturally just work. But you could, like, that might be another place where dialect could come into play, right? You could end up creating a dialect which is visible at the, for example, Java level, since you use Java. And your Java client could work with the operations that you defined in that dialect, which is visible in Java. But if you wanted to leverage more of the lower level code, you would need to translate it into a lower dialect that's sort of known by the rest of the JitBuilder implementation. That's one way that might work. I think that's sort of consistent with how MLIR works, in a sense. Like that idea of, like, not everything works with every kind of dialect. What I'm hoping to be is a little bit more inclusive, right? So as I understand it, I could be wrong about this, but as I understand it, the example that I showed with matrix multiply, where I defined a new type called complex, and all of the existing operations just work on it, I'm not sure that MLIR can do that because of the way it manages dialects. I don't think it lets you, and again, I could be wrong, but I don't think it lets you add a new type like that to existing operations. You'd have to define new operations which operate on the new type, and then if you wanted to leverage any code that was based on the existing dialect, you'd have to lower it into you'd have to completely lower your new dialect into the existing dialect. If that made sense. I feel like I'm rambling a bit, sorry.
Yeah, that makes sense. And then something like orthogonal to it, something that is not clear and that is usually, in my experience, a problem with libraries like this is that generating the code is easy, but then usually it's me who suffered that problem, is that you need to debug it, and that means not debugging the code generator, but actually provide a debugger for a language that you are implementing using the JitBuilder, and that's becoming hard. And for example, I played a lot with LLVM, and there is an API that allows you to generate dwarf metadata out of it, but because it was not built in right from the beginning, it's actually quite awful to do it, and then the whole things become much more ugly than if you just don't do that. So if I may have a wish, that would be to think about this early on.
Okay, noted. Thank you. That's exactly the kind of feedback that I'm looking for, because as I've said a couple of times, this was very early days for this. It's just a prototype. It's not set in stone at all.
Yeah, so, sure. I completely understand.
Yeah. Thanks for that suggestion. That's great.
How did J9 solve that?
How did J9 solve that? We created our own tool. That's what our DDR tool is for, right? It leverages some of the Clang debug info that comes out, and it also does some other kind of scraping of header files and so on to parse the offsets of various fields and structures, and then puts that all together in a set of kind of pretty printers that allow you to look at the data structures inside the JVM. from the point of view of debugging, I guess Java debuggers are kind of different beasts than native code debuggers, right? So again, they kind of solve the problem a different way, I would say. The one place where there is something of what you described is, I believe, in the Truffle Graal universe. I believe they have a notion of how to create a common debug format for all the polyglot languages that run on top of the Graal and Truffle, on top of Truffle, maybe on top of Graal. I'm not 100% sure where that. I guess it must be in Graal, but then probably exposed up through the Truffle API as well. I know there's been some research work done on that front.
Any other questions for Mark? Comments?
Is this something that will live in a separate repo or an OMR?
No, I think it'll live in OMR. At least it's currently, it's a good question because right now JitBuilder is an OMR compiler extension directory. So I'll have to, what I've done in my prototype, which is easy because it doesn't connect to anything yet, is I just created a subdirectory underneath JitBuilder called JBuild, which is the acronym I've been using for this work, JitBuilder IL. But I'm not 100% happy with JBuild. It's a good question. I do want it to live in OMR, but I mean, in principle, you could write backends for it for anything in principle, right? In fact, another interesting use case I was thinking about, especially in the context of the LLJB stuff that's showing up at the project, is that similarly to how I talked about having block builder and extended block builder, you could imagine operations that are implementing fee nodes or SSA that would simplify the translation of LLVMIR into a JitBuilder, this JitBuilder IL universe. And even potentially, you know, it could be something that you could operate, you could write SSA transformations on in principle if you wanted to. So I think it's a very good question about where it would go, but I think in the OMR project, probably sitting either inside or beside the JitBuilder project is where I would imagine it will end up. Well, if there aren't any other questions, I guess I'll extend an open invitation to people. You can write me emails or whatever if you think of questions after the call or want to ask me anything privately. That's fine. I will try to get the issue up in the next week, and I'll try to get my code committed after I fix the problem with the complex type right now. And I look forward to continuing to discuss with you all. Thank you.
Okay. All right, thanks, Mark. All right, that was our only topic for this week. So if there's no further questions, we'll adjourn. Thanks, everyone.